Right, morning. Almost ready. Yes, so today as we will talk about network access control and cloud security. And they are related because, I mean, if you talk about some type of cloud solution, some cloud service, you obviously need some type of network access control to that. But otherwise, they are targeting different areas. The network access focus on your own site. You have some system, and for that system you would like to have some type of access control. So that's a focus on that area. While cloud, of course, means that we have a system somewhere else. So let's start with network access control. So the main thing is that you have some type of network. It can be a wired network or it can be a wireless network. And you want to control who connects to that network. It's your own network, so you have control of it. You decide who can use that network. So you want to authenticate whoever goes into the network, but you also might want to do other things. You might want to check that they meet a certain standard before they connect to the network. So it's not only who they are, but also that they are, for instance, having a certain type of device, or that the device have a certain type of security profile in order to connect. We have different components in such a system. There are different names for these in different standards. So that is a little bit of a complication, but we'll start with these terms here. We start with the access requester, sometimes called supplicant, sometimes called client, the one who wants to connect to the network. So that is typically a computer or a mobile device that want to connect to the network. We have a policy server who decides what goes, who can connect, and what are the terms for connecting to the network. So that's also a system that is in the background. You control, you decide the policies, but you don't do the actual work of checking things or connecting. So that is the purpose then of the network access server. So that is the point for where the access requester tries to connect to the network. The purpose or the work of a network access server can be a little bit different, depending on how you build your system. You could have all the functionality of both the policy server and the network access server in the same device. Or you can split it. So the access requester connects to the network access server, who then in turn connects to the policy server to make sure that you meet requirements, and then gets back, and then you are let in. So it can either be only 2 steps or 3 parties in each connection. I see there are other names for it. It can be media gateway or remote access server. So there are different terms again. So here we have a system then. We have a number of supplicants up here, or clients or access requesters. We have a network, and typically this network is divided into at least 2 different parts. Could be even more different parts here. And then we have the network access server, which is the point of connection then. Inside the network, we have one part of the network which is an intermediate network that we have resources that are needed in order to check the access and also do some type of policing decisions. So this part of a network we can typically access directly, but only if the then meets some criteria we can access the rest of the network, and this is where we have our production systems, whatever we would like to connect to. In the network access server you can see that we potentially have different servers, or at least different services that can be in one device here. So we have authentication, we need to check that. We have a DHCP, so we can get an address for the client when we connect, so we can use that. It could be VLANs, that we have virtual LANs. We have to be connected to different VLANs depending on who we are. Inside here in the network you see we have a policy server itself, but then that one can point to, for instance, patch management. So when you connect, you have to notify what type of patch level you have or operating system and so on. And then you might have to update before you are allowed to connect to the network. Could also be antivirus, that you have to update those. And even you might have to run an antivirus scan on your device before you're allowed to connect, to prove that you are healthy enough to connect to a network. There are different methods, different standards for how to enforce these rules when you come and would like to connect to the network. So down here you can see different ideas. We have one protocol called IEEE 802.1x. That is called port access. So you get access to a port, which is could be, you can think about a port as an outlet for a physical network, but it can also be a virtual port that you connect to a wireless network. You can have virtual networking, as I said, that you connect to that one. And then, depending on who you are, you're connected to different virtual networks, and that is how you control what you can do. You can have a firewall, and then of course the firewall will filter traffic and decide that if you try to do something, you're allowed to do it, but if you try to do something else, you're not allowed to do it. So that way you can control how the network access should work. And you can do it partly by just your IP address. Depending on who you are, you get different IP addresses, and then that will allow you to do different things here. These are of course not the same level of protection. They offer different levels of protection, but also different hard to implement. These last three ones are quite simple to implement. The first one is more complex, but it also is more, gives you better possibility to control the traffic. So if we look at entire protocol stack here, that is involved in handling this situation. Now someone would like to connect to the network. You can see that we work on several layers here. Down at the link layer, there could be different type of networks. So here we have a point-to-point serial link, probably. Here we have a normal physical Ethernet. Here we have a wireless network, but there could be others as well. So it doesn't really matter what type of physical network we are connecting to. We can use the methods anyway. Then we have something called an EAP layer, which EAP, as you see, stands for Extensible Authentication Protocol. And that is a protocol that is doing just that. It handles authentication. You need to prove who you are in some way. This EAP protocol will look a little bit more closely at, but it's a framework for authentication. it says that when you do authentication, well, then you need to involve some parties in that one. You need to contact the network access server. There may be an policy server in the background. So there are certain patterns for communication that is needed, and that is described here. There's also a format for how to create the messages. So that is also controlled by it. But then you also have to decide on actually how to do the authentication. And you can do authentication in a very simple way or a very complex way. And that is not decided by this EAP. Instead, that is decided on the application layer here with different plugins, you can say, for EAP to decide on actually exactly how authentication should be handled. These are a few. There are quite a number of different protocols. For those of you who take the second course in mobile and wireless, will look more deeply into this. Then we have this middle layer here, 802.1x and EAP over LAN. These two protocols are helping to connect to the network. So the 802.1x handles the security, how to get access to a port in a secure way, how to encrypt the connection between it, and so that is handling quite a lot on how to connect to the network. While this EAP over LAN handles how to actually transfer these packets over different types of physical networks. And the reason why we may need this is when it's an adaptation layer. It can handle different networks, and it can allow us to communicate with the network even before we are authenticated. Because that's the idea. We need to send some packets to be able to convince the network that we should be allowed to connect to the network. But we need to do that before we are connected, right? So authentication methods then. Well, as I said already, we have the EAP who gives us a framework, and then there are a number of these methods that we can use together with EAP. EAP transport layer security, which is using the TLS protocol to create an encryption. We have tunnel TLS, which is a little bit more complex, because then you first set up an encrypted tunnel, and then inside that encrypted tunnel you start to authenticate, and you again encrypt the traffic. You have this generalized pre-shared key, which is a little bit simpler. You have, well, iKey, we'll come back to the iKey protocol later on. But you also have something called PAP, which is just plain password. You just say, well, IMI, this is my password. Unencrypted and very simple like that. So that's the easiest one. So you have many different levels of security here. Also, some of these protocols support different types of authentication methods. So you can use passwords or certificates or some biometric methods and so on. So that is supported by some of these. So the EAP then protocol exchanges occur between, and now we have a new term for it, the EAP peer in the EAP terminal. But again, that's a client or supplicant or request event. We have the EAP authenticator, which is the same as the network access server. And then in the background, we have an authentication server, the policy server in the general terms. So we exchange packets here between the peer authenticator at the EAP layer. But of course, it has physically to be delivered on a physical network. So here we use 802.1x or PPP, depending on what type of physical network we have. And then between the authenticator and the authentication server, we have also send messages. And now we typically use the radius protocol here. It's not mandatory, there could be others as well, but that is a protocol to handle users and authentication. And this shows the name of the messages that we send. So as you see, it starts with the authenticator, which may sound a little bit strange, because the first packet that goes here is that the network access point sends a message to the supplicant. But the reason is that below this we have the EIP over LAN. And that protocol will see that someone is connected to the network. And at that level, there will be a message sent to the authenticator saying something connected here on the physical network. And then the authenticator says, okay, now you have to identify yourself. That's the first thing that happens at this level. So we request the peer to identify. That is sent to authenticator, who typically passes it on to the authentication server. And then based on who we are, who we claim we are, we get this message back, say, okay, you are this person, you need to authenticate now in this way. So we'll get a request here to authenticate now. And that is passed on to the peer who responds. So it could be that we are requesting here, okay, give me your certificate. Or sign this message using your private key that is connected to this certificate. And then we do that, or we say that, well, sorry, can't do that. I don't have that. And then the authentication server can say, okay, I have an alternative method, so do it this way instead then. Give me your password, or whatever. So they can change a number of times here, as many times as the authentication server have methods that it will allow this, the peer to use. And finally, it either succeed or it fails with all the methods. So at the end here, we'll get that message, who will then be passed on through the authenticator to the peer. So after that, both peer and authentication knows that either you're allowed to connect or you're not allowed. Some terminology, I won't go through it, but you have it in the slides. All of these different things connected to 802.x. The terminology, I think we have touched on most things here, but there are a few more things. But you can look at it, and there's even one. Yeah, no, that was on the slide for that one. So now we are one level further down then, below the EIP layer. So now it's more a physical network connection. And at that level, we are talking about to control the access to the port, to the network through a port. And as I said, we talk about different types of ports. We talk about controlled and uncontrolled ports. So when the supplicant, which is the terminal at this level, connects to the network, we get a signal saying that someone connected to the network. At this level, we have these two ports here, uncontrolled and controlled. And since this supplicant is unknown to us, it hasn't authenticated yet, we only give access to the uncontrolled port here. So we can connect to the network, but we are limited in what we can do. That makes it possible for us now to start sending messages, these EIP messages, through the network server to authentication server. When the last of these messages arrive here, the failure or success, we decide on either to just shut off this port or to now open the control port here. So if you get a success message here on EIP, on this level here we open this port and now we can access the internal network. We also said that we have this EIP over LAN protocol, this adaptation protocol between the physical network and the EIP. And that also carries a number of messages with different frame times, as you see. So the first is the normal EIP packet that we just pass on these requests and authentication package and success failures on. We have this EIP over LAN start. So at this level, the supplicant can send a message to the network access and say that I would like to authenticate if the network access server didn't respond when you physically connect to the network. Normally you get that if you physically connect to a port, usually the switch or whatever you connect to report to the network access server someone connected now, and it will immediately contact you. But if you have older devices, the switch may not give that signal. So then the supplicant can say, hey, I connected, please let me in. And then we have a log off. We are done. Usually, maybe you don't use that, you just disconnect, but you can log off. And you have some key related messages that you can send to exchange cryptographic information. So if we combine this now, both the EAP and the EAP over LAN, we see that, okay, now we start with a start message instead, if that is needed. And then comes the request identifier here, who is passed on, as I said before, to the authentication server. And then we have this exchanged until the authentication server is either happy or decides not to allow you. And then you, after this stage here, you will have a connection to the network. So now you can continue to send normal messages. And then at the end you do a log off if you're nice. So we won't go into network access more deeply than that. As I said, we talked about the radius protocol. We'll look more closely at that in the second course as well. But that, what you do is you set up a radius server on the authentication side where you give your users and credentials and how they authenticate and so on. And then there are special messages going between the network access server and the radius server there. Instead of having a radius, we could have an LDAP server there. LDAP is a type of database system, distributed system, where you can also keep track of users, and you can use that to make a query to the database from a network access server and see if you're there or not. So that's an option. There is also a protocol called TACAX and TACAX Plus from a Windows world mainly, that is also doing similar things, that you can control authentication and access. Yes?
What would be like the difference between LDAP and the radius protocol, like in the sense that what functionalities can be exploited in LDAP and are not used in radius?
Yeah. Well, the question is the difference between LDAP and radius, and radius is focused on authentication. So that's the main thing. You want to authenticate, and then so the protocol is developed to create these measures how to authenticate. So that's the main thing with radius really. With LDAP, the focus is more on the database side. What type of information? How do you store information? You create a tree structure in a certain way, and an LDAP database can be used for other things than just authenticating users as well. So it's a broader concept, but it can be used for authentication as well. So yeah, I would say that Radius is the first choice here, typically. So there are quite a lot of options, and if you think about it, first you have different type of clients. You can have different types of network access servers, and you can have different types of policy authentication service in the background. You can have different authentication protocols. You can store users in different ways, and then on top of that you have to choose different type of authentication methods, and you have to, if you decide on a method that use certificate, for instance, you need to be able to handle certificates and distribute certificates. Then you need, all of these require different type of encryption function, of course. It could be symmetric encryption, public key encryption, hashing. So depending on what you choose there, you also need to make sure that you support those methods. So there are lots of different steps and lots of choices when you build up a system for this. And those choices depend on, of course, what type of clients you have, what do they support, because there are limited support in all different clients. If you have an old Palm handheld, it doesn't support anything. If you have a new BlackBerry, it support more. If you have a modern smartphone compared to a laptop, so all of these support different things. And depending on your choice, you will only support some devices. And then you have to decide on the security level, how secure does it have to be, and so on. So there are endless decisions to make, and of course a lot of testing needed in order to make sure that it works. Right, so that's network access. Now let's move on to cloud computing then. So as you see, we have a definition here of what cloud computing is. So a model for enabling ubiquitous. What is ubiquitous? No one heard that term before. It means available from anywhere, you can say. So it should be a service that you can have wherever you are. That is what ubiquitous means. So it should be ubiquitous, convenient, well, we know about that, on demand. And with on demand, we will look a little bit more deeper on that, but it means that you request some service from the cloud, and suddenly you decide, well, now I would like to increase the size of that request. Instead of having one server here when I do my computation, I would like to scale it up to 100 servers to do a parallel computation. And that should be done just like that. Done, I request it, I have it. So on demand means that whenever we need something, we could just ask for it, and the cloud server will provide. And we have that to a shared pool. So we share it. It's a shared resource. Well, it doesn't have to be all the time, actually, but in most cases it is. Configurable computing resource, and it's general resources. See, it's not only computing resource, can be network service, storage, applications, services. So any type of thing that we would like to be able to connect can be thought of as cloud computing. And it can be rapidly provisioned. Well, that is the on-demand thing. We can say, yes, I want it, and it should be easy to get it. Released with minimal management effort. So here comes automation in. It has to be a system that doesn't have to have a lot of manual configuration if we would like to do some changes. Promotes availability, composed of 5 essential characteristics, 3 service model and 4 deployment models. Well, this was the initial definition. As we see, that has been extended, so there are more different models, more service models and deployment models today. But we'll start from there. So here we see the cloud computing elements. So here we have these 3 areas, the deployment models, the server models, and the, what they call essential characteristics then in the standard. So if you start at the bottom here, the deployment models tells us on how the cloud is used. Public being perhaps the most common one, the most that we think about. We have lots of public cloud services. They're available for anyone, and we typically share resources with anyone. We could have a private cloud. That means it's not for everyone. It's limited to who can use it. And the lab cloud we have that some are used for the server administration course, for instance, is the private cloud solution. Then it can be, well, community means that they are limited. It's not for everyone, but it's not just for one. So we have a community who shares it. And then hybrid means that there can be combinations of some of these. There can be parts of the cloud that is private, part that is public, and so on. If you then move up to the service models, these 3 are the first types that were defined. We'll look at them more closely. So let's leave them for now. And then we have the characteristics, which we more or less already covered when we went through the definition here. We have a resource pooling, we have shared resources, and we can allocate whatever resources is needed in a certain moment for a client. We have on-demand self-service, measured service. Well, since we are normally paying for the resources, we need to be able to measure them and later on build them. Rapid elasticity, that means that we can scale up or scale down to our needs, and the cloud should be able to support that. And broad network access, well, since the cloud should be connected through the network, of course, we need to make sure that we have good network connections for it. So, well, it's just chosen in principle how it works then. Here we have some type of enterprise. We have different clients in this enterprise. We have a network here, of course, a private network that makes it possible to connect to the internet or to a global network at least. But then all the services around down here by the cloud provider, who have these pools of resources that it can allocate for different clients at different stages. Yeah.
When you mean network, does it mean like wide area network?
Well, with network here, this would be a local network, of course. This is our enterprise network. But this would be a wide area network. I mean, we are connected to, it doesn't really matter where we are. We should be able to connect, we said ubiquitous. That means that wherever we are in the world, we should be able to access the cloud here, the cloud resources. So, and of course, most of the time we're talking about the internet here, but it doesn't have to be internet. It could be other networks as well, but with a wide range, of course. To facilitate building up different cloud solutions, again, NIST here made what they call this reference architecture. It's not meant to be used as as a model for how you must build a cloud or fit it into the current cloud structure we have. But it gives us a good idea on what things could be important when we are using or building cloud services. And this reference model not only talk about the cloud solution itself, but also about things around it that could be important. So this is a picture of this reference architecture. And as you see, there are different blocks here. We start down here with a cloud carrier, which typically is just a normal network carrier. So this is just the basic network. What could be specific here is that, of course, a cloud needs to be available at any time. So the network access is even more important than for many other services, which means that a cloud carrier for a cloud provider typically have a better network, and a network that have many parallel communication links to different parts of the world. So even if we have problems with the network, even if part of a network is under attack for a denied service attack, something, we can still reroute the traffic so we can still service our customers. So it's a better quality network, you could say. What else do we have here? Well, of course, we have a cloud provider that provides the services for us. And that cloud provider, of course, have all the things that we talked about before. They have different types of services. We'll come back to those again, as I said. These can be what we call a service orchestration. So we can have a set of different levels of services so we can combine them in different ways. So that's what the cloud provider offers to us. They have, of course, hardware. They need to be able to handle that. Typically, they have lots of redundant hardware. They have this hot swap that you can, something fails, you just swap it out, put in a new thing, and it's automatically gets started in the system. Management of the cloud services means that we have a way to register users, to be able to possibly pay for what you have and so on. There should be some layers here that talks about security and privacy. From our point of view, maybe we think that the security should be bigger than that, not just an afterthought here, but security is of course important, and we'll talk about that specifically. Privacy they have especially. Privacy, I mean, that is part of security, normally we say. But the reason for why they have privacy as a separate thing is that that is one of the focus points when you talk about security in the cloud. Because what we have is typically data, that's potentially sensitive data, that we now have somewhere else. And of course that gives us certain concerns that we have to think about, how to handle, who can access that data, who can change that data. We don't have physical control over it anymore. So that's why privacy is elevated here to a separate box. But then we have two more roles here, as you see. We have a cloud auditor. Well, we have three roles. We have a cloud customer, that is us. But apart from that, the cloud auditor is, as you see, standing next to us. That is actually our partner, you can say. It's a separate organization from the cloud provider. The idea with the cloud auditor is to do, as you see, security audits, privacy impact audits, performance audits. So they are checking cloud providers. making sure that they are living up to different requirements. It could be that you as a customer ask a cloud order to do special tests for you, but it's also typically that they are running general tests and checking that the cloud provider live up to certain regulations and so on. So the idea is that as a cloud customer, you don't have expertise to know that the cloud provider is doing things in the right way. So you go to a cloud to help you evaluate the cloud provider, make sure that they are doing what they should do. And then we have a cloud broker. And that is also a separate organization. And they also can help a cloud customer to decide on what type of cloud provider, what type of solution they need for a certain problem they have. So see, things that the cloud broker can do is service intermediation. That means that they can go in as a middle hand between the customer and the cloud provider. So you go to the cloud broker and say, well, I need this type of service. And the cloud broker can help you investigate your needs and then select a cloud provider that fits what you needing to know about all the different cloud providers that potentially can do it. They can do service aggregation. That means that they can say that, okay, you need a service. That service is a critical service. We couldn't rely on just one cloud provider here. So let's split that into and use several cloud providers. But then, since we split it, that of course adds to the complexity. So we need to manage that somehow so it seamlessly is one solution. And that can be done by the cloud broker. And arbitrage, they can also negotiate between you and the cloud provider to get the best service from the cloud provider for you. So see, there are quite a few different actors here with different roles in this architecture. And I think that, yeah.
So, cloud provider can't exist without these cloud broker and cloud.
Right. What is needed? Well, this is, of course, not all of this is needed. I mean, you could set up your own private cloud. If you do that, you are both the cloud consumer and the cloud provider, and you don't need the rest. So it really depends on the situation. What of these parties are needed? Well, I think this slide actually already talks about what we have talked before. We can go into the bottom row here. Start talking about these different service models that we have. Because we said already up here that we have these software as a service, platform as a service, infrastructure as a service. So what are they? Well, if you look at software as a service, that means that the cloud provider deploys, configures, maintains, and updates operation of software applications. So now we are servicing a software or a service. And the cloud provider handles all of the management of that. That means they are handling the physical machine, they are handling some type of virtualization layer, they also handle the operating system that the service is run on, they also handle the application itself to update and so on. So you as a customer only connect to the service and use the service. You have no idea how it's managed in the cloud. Can you give some example of SaaS services in the cloud that you use? Email, yeah. If you talk about Google email, for instance, I mean, Google have a lot of cloud services that they run, that you use. If you look here at the university, Time Edit is a software as a service that we buy from another company. So we only buy that service. It's not run here at the university. Then we have PaaS, platform as a service. And now we see the cloud provider manages the computing infrastructure, runs the cloud software, and provides the components such as runtime software, execution stack, databases, and other middleware components. But it doesn't run the platform. So what you get here, you can say, is a virtual machine. You can run your own virtual machine. You can install an operating system, and you need to update that. You can run different programs on and so on. So you have a platform, a virtual operating system in the cloud. And then we have infrastructure as a service, where the cloud provider again provides a basic platform, and it provides underlying services. So that means that you can set it up, but then you define an entire infrastructure, which means that you can define a number of virtual hosts, you can define networking to connect to them together and so on. So you build an entire infrastructure in the cloud. An example of that would be our CS Cloud that you use for some of the labs. That is an infrastructure as a service. Okay, well, let's take a break until 1:15, so 10 minutes break now. Social engineering is an active well, depends a little bit on exactly how you define this. Of course, if you have reconnaissance, you are just reading about information about the person or trying to get that is part of a surgery. That is passive. But say that you are contacting someone when you have to say, hey, I'm busy, you need to do this. Then of course that is an active.
Requires some action and then it's
yeah.
no action is required.
Yeah, or if even if it's only that it's visible that there is something wrong, it's an active attack.
Oh, you did?
I mean, a passive attack is principally invisible to us because it doesn't change anything. Something that we can see.
Another question. Not all of the improvements, they are not required.
No.
That's why we recommend it.
Yeah, because they are support functions for the cloud.
is listed as a song the back of the car. You know, a huge pan with black Johnny Hawkins on it. Turtle bot.
You just have to learn them by heart. That's all the time. By the way, that was the Swedish tax. Like if it's like half an hour, 5 minutes. 5 minutes or 5 minutes to half an hour of tapping.
To be honest,
How would you say 25 plus?
you could say like 5 minutes before, like 10 minutes.
That's how I. But it kind of rolls on
You say 5 So
Yeah.
5
5 house. 5 innan.
Yeah. Oh, that's a good trick. That's actually a good trick. The E49 before. Finally, something you can supermarket with no computer.
That's what it's all about. That's what this is all about. I just can't imagine why anybody would like to learn Swedish. Useless. It would be, basically any other language would be better since it's not here. Such a small country, it's not here, but I mean.
Well, there you go. That's the use of it.
Well, you guys be everyone here from the supermarket, I bet.
Well, not supermarket, but like you could work.
I am.
From German to Swedish, it's not very far.
No.
Or from the Netherlands, from Dutch to Swedish.
It's tutorial for this one.
And from Spanish to Swedish is like the movement.
Tutorial call.
saying sentences.
Many of the Netherlands
Whatever they say. It sounded like you were joking. Like when you said
Honestly, Spanish.
No, I don't like to write on this.
It sounds highly confident.
No, Latin is so strong when I write. See, because now this one
except the articles, because it's also real and stuff like that, and it's not really a rule, but you can always follow the ending of the single word. You can finish it in a, mostly and email and so on. Except
Okay, let's get started again. Right, so these roles and responsibilities were already covered, so we can move ahead and start looking then at security risks and countermeasures to handle security risk. Because so far we only talked about the cloud service, and we said that there should be some security and privacy. But what is it? Well, we start with this list as from 2010 from something called the Cloud Security Alliance, which is an alliance between different cloud providers and security companies. And as see here, they are talking about possible threats. The first one then, abuse and nefarious use of cloud computing. What would that be? Well, that would be that someone is using the cloud in the wrong way. And that can happen because the idea with the cloud resource is that it should be accessible, it should be easy to set up and manage, which means that it's also easy from an attacker to register and set up a service and maybe exploiting the cloud in the wrong way. So what is needed here is to have some type of check on customers, that they are real customers or real users when they set up, and they don't misuse the services, but it seems to be using them correctly. Because otherwise, of course, the cloud will be, well, if we use it quite a lot for wrong resources, it will affect other users of that cloud. So that's one concern. And then we have a malicious insider. We have resources, we have a cloud, we have lots of data from different customers. Oops. And of course, an insider, one who's working with a cloud provider, could potentially do quite a lot here. They could control the services, they could possibly access the information that is stored in different cloud customers, part of the cloud and so on. So this is of course a concern that the customer have, that someone will attack them from the inside. So to handle that, of course, the cloud provider needs to have controls within the company to make sure that they don't give more access to their employees than they need, that they have legal contracts, that they have maybe audits from outside showing what their staff is doing and so on, to give it trust here. Then we have insecure interfaces and APIs. I mean, a cloud is a visible resource. It has to be visible. It has to be on the network. It has to be accessible from anywhere. So there are lots of interfaces. And in order to orchestrate, in order to set it up, you typically have different APIs so you can automate and you can do things in a quick and efficient way. And that means that all of these are, of course, also possible to attack from outside. So hackers, malicious code and whatever can try to hack these interfaces. So here we need then to secure all of these interfaces, to limit what they can do, so they can't do more than that, with checks of data coming in, firewalls, whatever, secure interfaces. Then we have this shared technology issue. The idea with the cloud is that it should be shared, because that's how we get this service that is very flexible and it's relatively cheap. So it needs to be shared. But since it is shared, there are potential problems. Because even if you are using different type of virtualization to try to put different customers in different virtual environments, they still share the physical resource. And depending on what type of virtualization we're using, we can more or less affect each other. So that is something, and if you remember those took the computer security course, we talked about this possible information leak that can be done doing in very different ways. There can be information leak by looking at the performance of a system right now. We are running a system and then someone else is running at the same time on that physical system. We can see the effect of that other user by seeing how the performance for our process is running. So we can see if someone else is doing something heavy or not. Maybe that can be used to extract some information about our neighbor. And there are extreme cases when you can, by looking at the sound of a computer resource or looking at the level of power that is used, you can actually extract encryption keys from another customer even. So it is a real issue, this. Then we have data loss or leakage, which is a big problem. You have your data in the cloud for convenience, but your data is potentially sensitive and potentially business critical. So of course you want to make sure that the data is not lost or leaked. Either one could be catastrophic. So here you need, of course, to do different things with integrity encryption of the data, different types of backup routines and so on to make sure that data isn't lost and so on. I mean, this is a crucial part for a service provider to ensure for the customer that your data is safe. But also, you as a customer can do things here. I mean, you can make sure that the data you put in the cloud is already encrypted. So it doesn't matter what the provider is doing or someone who attacks the provider. Your data are still safe. And you can make sure that your data is replicated on several cloud providers. So even if one crashes or goes bankrupt, your data is still available somewhere else. So here you couldn't just rely on the cloud provider. The list continues with different possible threats with account and service hijacking, which of course would be bad because then they would potentially be able to access your data more easily by hijacking your account. So here we need good authentication methods and maybe intrusion detection systems and so on to make sure that we can detect that. And we have one called unknown risk profile. Are things that we don't know about, of course, in order to make sure that we detect things that are potentially new risks. We do different type of monitoring to capture things that are not normal behavior. So that was from 2010. And that was the book is talking about. There is a new list from 2016, and that is actually the latest one that we have published from this Cloud Security Alliance. And now they are talking about 12 different threats here. So a little bit more, and the order is a little bit changed as well. So you see the highest threat are data breaches. And I think you can relate to that with all the press that has been on data leakage from different services. When it happens, it's often catastrophic or at least very, very bad. And when it happens, it's often huge data repositories that are stolen. So that's a big, big thing. But then we recognize most of the things that had insecure interfaces. System vulnerabilities was a new one that they seen, that actually the cloud provider have vulnerabilities in their own systems that they hadn't thought about. That wasn't listed before. These advanced persistent threats is also a bit new, because that is a new type of threat that has emerged in general. Of course, that will also affect clouds. Insufficient due diligence. Anyone know what that is? Well, that means that you don't live up to regulations, laws, and well, there are rules that you need to comply to. And if you don't do that, you don't have due diligence. So they are not checking that enough. So that's from the cloud provider side then. Denial of service is also a new one, but that should have been before as well, I think. So even if the threat picture is changing a little bit, and we see that in general, I mean, there are new threats emerging, and then they are climbing in relative compared to other threats, and then they die out when we find methods to deal with them, and then new other threats emerge and so on. So it's not surprising that the same is true for cloud computing then. Again, a long list, I won't go through it, but they talk about, as you see, guidelines on security and privacy issues and recommendations for a cloud provider, but also for the customer. These are things that you should look at when you select a cloud provider for your service, and what things you actually put in the cloud. Some services, some data you might consider not to put in the cloud because of the security concerns. So see, there are a lot of things that you should think about. Governance, compliance, trust who you trust, the architecture of the system, how you handle identity and access management. If you handle it yourself, if a cloud provider handles it, or if you have a third party in a federation, for instance. Software isolation in the cloud. Yeah.
Does the cloud audit also make sure that the security guidelines are up to date?
Yes, the cloud auditor, that role we talked about before, they will help us with that. So we can go to a cloud auditor and ask them to check that the cloud provider meets up to this. Yes. There is continuous data protection. Availability could, of course, be an important thing. And incident response. What do they do? What type of routines do they have if incidents occur? Do they go do they report it to the police, or do they handle it internally? Do they have technical capabilities themselves, or do they hire that and so on? So a lot of things. But there is, of all of these, there is one that we'll focus in on, and that is the data protection part. So the data protection, as I said before, that is also, if you go back up here to this list, I mean, data breaches is the main threat, and that is handled by data protection then. So, the threat of data compromise. And of course, since we now have our data in the cloud instead of on premises, there is an elevated risk. There are risks because the cloud is more visible, it's easier to attack from outside, and we have a malicious inside in the cloud. So the threat surface or the attack surface is much higher than if we have the data in our own premises. there are different models for cloud, as I said. We have this called multi-instance model, and we have a multi-tenant model. That is how we build the virtualization, you can say. So think now that we have our data in a database, and that database is run by a cloud provider. So in a multi-instance model, as you see, we are running unique database management system for each client. So your database is run by one database management system in one virtual machine. Another customer have another database management system running in another machine. So they are logically entirely disconnected. Of course, they are physically still on the same machine, possibly, but they are logically separated at least. While the multi-tenant model means that we are actually in the same database management systems. We may have different tables there, we can have different authentication, but they are running in the same database, and there is always this risk of leakage of data when we are in one database. Why this is even considered is, of course, that it's much simpler and cheaper to run, but it's less secure, of course. Now, when we talk about data in the cloud, it's not only data that is in the cloud itself. We have to think about data in all the different steps. While at rest, while it's actually just stored in the cloud, in transit, when we are sending and receiving from the cloud, what happens with the data there? Where does it go? Is it secured? Who can access the data while we are sending it? In use, well, in use typically means that in use in the cloud. If it's in data in a database, for instance, we are making a database query to the cloud, and then we run that query in the cloud. And of course, while we run that, the data is used, and potentially it can be leaked. So we have to think about that in all these different phases. The client can, as I said before, we can encrypt already before we send to the cloud. That will protect the data in transit. It will protect the data while it's in the cloud. But it will make use much harder. Because if our data is encrypted in the cloud, it's limited what we can do with it. If we need to use it, we need to decrypt it. Well, where do we decrypt it? Do we decrypt it in the cloud and run some type of operation on it? Or do we have to fetch it, decrypt it, run the operation locally? Well, if we do that, we're not fully using the cloud model then, because now we are actually doing things on a local basis, part of it. So if we want to run the operation or the well, whatever we're doing in the cloud, in the cloud itself, we have then two options. Either to decrypt it, which lowers the security, or we can potentially do things while it's still encrypted. We'll look at that option actually. Yeah, I think we can go on here. So this would be a solution then to actually have the data encrypted on the cloud server and still be able to run queries on it. To do that, we need these different roles here. We have a data owner. That is one who owns the data, who knows them. They have, of course, access to the data unencrypted, and they also have metadata. What they do is data owner is encrypt the database and then put it in the cloud. This metadata can also be given to potential users of it, and these users can be our own users, or it could be that we have a database with information that we want to be used by other customers. I mean, this database could be, let's say, stock exchange transactions or whatever. And our customers are different businesses who would like to do analysis on the stock exchange. So they would like to access that data. And we can sell that as a service. But we have done some analysis or something that makes this data valuable. So we want to have it encrypted. So it's not accessible by anyone. Not even our users. They can do different types of analysis, but they couldn't access the data directly. So how would that happen? Well, they get this metadata from the data owner. They can do different queries, but the queries couldn't be run directly because the data is encrypted. So what we do then is we have this query processor who actually reforms a question into a database management question that can be run on encrypted data. And then we send that query over to the cloud. We run a query. We get some result, which is still encrypted. We send that back, and here we can decrypt it. So the client gets a plain text result of a user. The cloud provider never sees anything but encrypted data. This does not work in a general case. It doesn't work for any type of data in any type of database. But for some types of data, it does work. Well, I mentioned that when we talked about encryption, there are encryption methods that makes it possible to actually run queries on data while they're still encrypted. We just mentioned it. We didn't. It's not the normal encryption methods. Yeah.
Doesn't that compromise the security of the data? Like, is it more secure, like an encryption method that where you cannot perform queries in, or does it make any difference?
Well, the security we get here is twofold, actually. One is that on the cloud, the data is always encrypted. So anyone hacking into the cloud trying to extract the data will only get encrypted data. So that's how we get data protection here. The user are limited in what type of queries they can make based on this metadata, which means that the user can be limited, so it couldn't do a query, for instance, for separate data fields here. It couldn't extract exact data, but they could run a query that says what is the average of all the fields here, for instance. So they can get aggregated data, but they couldn't get specific data. And we can limit that here. So that is how the data owner protects itself from the customer. So the customer couldn't do things that the owner doesn't want. So we get protection in both these cases. Yeah.
What's the essence of the metadata for the client, or is it the same metadata for the data owner?
It can be different. I mean, the metadata we have here at the owner is complete. That is what the owner needs to be able to encrypt the data in a certain way, but then different users can get different parts of that metadata just because what that user will need to do. So we have access to just part of it. So that is a way to control what we can do with the data. So this is quite complex, but it is working and it's used more and more to protect data if we store it in a database. But it is limiting what type of query we can make, so it's not working in all cases. Then we come to another aspect of security in cloud. We said that we have 3 different models. We have service as a service, or software service, platform, and infrastructure service. 3 different service models. But now we add a 4th And if you go to Wikipedia and ask for cloud service models, you will find that there is a long list now of possible service models from the cloud. But in this context of security, of course, this one is interesting. So, security as a service. How can we use the cloud model to get security? Well, as you see, there are lots of ideas on how to use the cloud to increase the security. Identity and access management, well, that could be a federated solution, for instance. How can that give us extra security? Well, someone who is a professional in handling identities and authentication can do that better than we can do, probably. So that can actually increase the security. Data loss prevention, by using several different clouds and aggregate that together, so we can get security for data loss. Web security, well, the idea is to proxy your web request to a cloud service. So whenever you are surfing web, instead of surfing web directly, you do it from a proxy in the cloud, and that proxy will check all the requests, making sure that nothing malicious gets to you from the other side. You know that there are a lot of these drive-by hacks that when you just go to a page and you get some malicious code. So that can be stopped by that type of solution. Email security, the same idea. You put your email in the cloud, and that can scan emails to find all the different types of malicious code and possibly spam and so on as well. Security assessments. You can get security as a service, like service inspections of your premises. You can get sort of penetration testing from the cloud on your premises and so on. So that can be done a different way. Intrusion management. To do that, you need to send your traffic that is normally going in and out from your premises through a cloud provider, who then can check for intrusion detection and handle if there are new types of attacks that can be automatically stopped and so on. So it's just putting your intrusion detection system in the cloud or instead of running it yourself. Security information event management, that is a monitoring system that is looking at different patterns of network traffic. It can also look at what goes on in different servers and automatically analyze and warn if there are things going on. Encryption, of course, we can put that in the cloud to encrypt different things, but that sounds a little bit suspicious, because if you put the encryption in the cloud, that means you have to send it there unencrypted first. So yeah, maybe not, but yeah. Well, lots of ideas on what we can put in the cloud, and this is just a model for showing where that could fit. Doesn't say very much, but down here we have a cloud service client that will put part of security in the cloud. And then, of course, there are, in the connection between the client and the cloud, there are things like identity access management and network security, like ordinary firewalls and so on, that is needed to secure the access to and from the client and the cloud. But then in the cloud, we have all of these services we mentioned before. We could have our web proxy here, we can have our intrusion detection system, we could put our email, we can have this data loss prevention with the application and so on. So that's the idea. Instead of having all of these systems in your own network, you put them with a cloud provider. who is a professional at handling these type of security services. So you outsource part of your security in that way. And I would say that in some cases it will increase your security. In some cases it will give some benefits but also some drawbacks. So you have to consider what to put in the cloud, what is perhaps best to run yourself. Right. That was the last slide, which means that we will have time for a Kahoot today. Finally. So, bring up a web browser. Ska vi se, ska vi plocka hit den först. So, you on distance as well, you are welcome to join. What you need to go do is, if you haven't used Kahoot before, go to this kahoot.it and then enter this PIN number. And today we will go back a little and check that you remember everything from the encryption lectures. So that's the area for today. Only 7 questions, so it's a quite short Kahoot, and hopefully the average will be, let's say, 1 missed question. So you should have at least 6, I think. But there is this element of competition here, as you know, which means that you have to be fast in order to win. But if you're too fast, you might make mistakes. And if you make a mistake, you will get 0 points. So read the question carefully and all the options before you decide. But try to do it fast. Okay, is everyone in? Okay, then we'll start. Can find the start button. Yeah, here it is. Maybe we should have some sound. It will. Yeah. Right. Okay. The something is the original message before transformation. And 5 didn't get it quite right. The ciphertext is, of course, what we get after our transformation. And then a few said none of the above. What did you think about? Why would plain text not be correct? Sorry? It was a mistake, okay. Yeah. But we take the plain text, we put it into the transformation to encrypt it, and then we send the encryption. Okay. So, who's Jojo Siva? Ah, nice. But it's close in the top here. So, next one. Next one. Okay, looks pretty good here as well. And algorithm transforms plain text to ciphertext. So the first step here to actually do the encryption. Decryption is then the reverse operation. And either A or B. Well, in some cases, it could actually work. I mean, you could run a plain text through a decryption algorithm to get a ciphertext. But that's not the terminology we use, even if it's technically possible to do it. Oh, new leader, Nils. Who's Nils? Ah, nice. Okay. Next one. Next one. Not so good. Okay. So the options were public or private. I mean, those are options we have. And most of you actually guessed wrong then. Was it just a guess, or what did you think? Yeah. For confidentiality, that means we are the sender side now. We would like to have confidentiality. For confidentiality, that means that when it arrives, it's only the receiver who can decrypt it. And to reach that, we must use the public key of the receiver to encrypt it. And when it arrives, it can be decrypted with a private key. But when the user has to use the public key of the receiver. Okay, a new leader again. Top 5 have managed to have 5 right so far. Okay, next one. Okay, better result. I mean, this is in principle the same question as the last one. We just turn it around a little bit. For confidentiality again with an asymmetric key, but now we're talking about on the receiver side. So exactly the same message that we encrypted last time with a public key, we now need to use the private key to decrypt. I'm glad that it was an improvement. But still room for improvement further. Ah, who's fits 90? Ah, on fire. Good, okay. So CC cipher is exactly as most of you said, a substitution cipher. A transposition is also one of the basic methods, but it's not used in the CC cipher. Can you give an example of a transposition cipher?
Hill cipher?
Sorry?
Hill cipher?
Hill.
Yeah, we took that in crypto.
Okay, yeah, I didn't know that one, but simple permutation, for instance, is an example of that. Yeah, I understand. I get the question here or comment on the stream that they have hard to read the example answers. It's it would be better if I could share the screen correctly, but yeah, you will have to do what you can. Sorry. Still, it's 90 here, but the lead is not that great, so things can happen. Okay, next one. Okay, next one. Excellent. I mean, this could be pretty tricky, but RSA, which comes from, what is it called, RSA?
The surnames of
Yeah.
the three people.
The surnames of the three people. Rivest, Adelman. Something, yeah. Oh, increased lead here. It will be hard now to beat Fitz 90 here. I think it's one more, or is it? Yeah, we'll see. Yeah, last one. Yeah, about the same result as before. It's still a substitution. It's still, for instance, CC cipher, we take one, we replace it with something else. If it would have been transposition, it would have been moved around, change position, but not replace it. So, I see that some of you need to study encryption a little bit more. And now you know who it is. Whoops. What? What happened? Did you get it wrong?
Now you know that I choose transposition.
Okay, I'll see. So, good. If we have time, we will have another Kahoot that will be more general information security next time. So we'll see about that. But we'll meet tomorrow again, right? Yeah? Okay, fine.